Good morning, friends. Today we discuss the illustration starting from the 4. Already 1, 2 and 3 we discussed. Now, fourth illustration is given that what is the de Broglie wavelength associated with first for an electron moving with speed 5.4 into 10 is to 6 meter per second and a ball of mass 150 gram traveling at a speed of 30 meter per second. Only we have to calculate the de Broglie's wavelength. Already we know that the de Broglie's wavelength lambda is equal to h upon p. P is the momentum. We know that the equation of momentum P is equal to mass into velocity m into v. That means we have to find out first the momentum of electron and given ball. And then we substitute this value of momentum in equation of de Broglie's wavelength lambda is equal to h upon p. Clear this? Okay, let's recalculate. Now, Planck's constant h is not given. That is the 6.63 into 10 is to minus 34 joule into second. Right? Okay. Now, de Broglie wavelength lambda is equal to h upon p, or we can write h upon mp, h we wish. So directly substitute the value in this equation lambda is equal to h upon mp, we can obtain. Or first we calculate the momentum of electron and ball, and then we substitute the value of momentum in this equation, we can also obtain the wavelength. Okay. For first part A, for an electron, mass of an electron Me 9.11 into 10 is to minus 31 kg. Now, speed of an electron VE is given 5.4 into 10 is to 6 meter per second. Therefore, momentum of an electron is P is equal to MeV. That H is substituted the value of mass and speed of the electron. We obtain the momentum of an electron is 4.92 into 10 is to minus 24 kg meter per second. And de Broglie wavelength for electron lambda is equal to h upon p. H is 6.63 into 10 is to minus 34 upon momentum. Just we obtain 4.92 into 10 is to minus 24. Right? Thus we obtain the value is 0.135 nanometer. Calculate yourself. There is the wavelength of an electron lambda. The similar way, we can also calculate the wavelength of a given ball. B part for a ball. What is given? Mass of a ball is 150 gram. That means the 0.15 kg. And the speed of a ball, so the diameter speed 30 meter per second. So the same manner we can calculate the momentum, and then we directly substitute the value of momentum. Momentum of a ball P is equal to mv. So we can obtain the momentum of a ball is 450 into 10 is to Mass is given the 0.15 gram, and that is the 30 meter. Therefore, 450 kg meter per second, 4.5. Calculate yourself the momentum. And de Broglie wavelength lambda is equal to h upon p is approximately obtained 1.47 into 10 is to minus 3 meter minus 34 because h is minus 34. So 1.47 into 10 is to minus 34 meter is the wavelength of a given ball moving with the speed of 30 meter per second. Clear this? So that is the wavelength of electron and that is the wavelength of a given ball. Now next illustration is 11.5. An electron, an alpha particle and a proton have the same kinetic energy. Now which of these particles has the shortest de Broglie wavelength? For that purpose we assume that the mass of the electron is m, mass of the alpha particle is m alpha and mass of the proton are mp. Suppose mass of an electron is m and de Broglie wavelength or the momentum, or directly we can write suppose the mass of electron is m and mass of alpha particle is m alpha and mass of proton is m. Now we know that the mass of the electron is much smaller than the mass of the alpha particle, is much smaller than the mass of proton. Sorry, the mass of the electron is less than the mass of proton is less than the mass of the alpha particle. Because the alpha particle is the 2He4. That means that is the mass of the alpha particle is double than the mass of proton. Mass of proton is 1.67 into 10 is to minus 27 kg, while the mass of the electron is 9.11 into 10 is to minus 31 kg. So mass of the electron is smaller compared to the mass of proton, and mass of the proton is also smaller than the mass of alpha particle. But kinetic energies are equal. Therefore, kinetic energy K is equal to P square upon 2m. There is the relation between the kinetic energy and momentum. Therefore, the momentum P is equal to under root of 2m. 2m. Now, de Broglie wavelength. Lambda is equal to h upon p is equal to h upon under root of 2m k. So there is also the important equation. If the kinetic energy of a given particle is given, what is the de Broglie wavelength of this particle? Right? So sometimes the numerical or the objective question is also asked on the basis of this equation. Kinetic energy given. So at that time the de Broglie wavelength lambda is equal to h upon under root of 2mk. Now for given this phase particle, here the kinetic energies are equal but the mass are different, h is constant, therefore lambda is inversely proportional to the square root of m. Therefore lambda is inversely proportional to the 1 upon under root of m. Right? Okay. So here the relation between the wavelength and mass is inversely proportional to each other. Therefore the mass of the electron is less. Therefore the de Broglie wavelength is more. Now the mass of the alpha particle is more. Therefore de Broglie wavelength of alpha particle is less. Therefore, thus alpha particle has shortest wavelength. Shortest wavelength. And the electron has the largest wavelength. Therefore, the wavelength of alpha particle is less than the wavelength of proton and less than the wavelength of electron. Clear this? Only we have to obtain the relation between the wavelength and mass. Because the kinetic energy are given same, H is constant, H is constant, 2 is constant, and K is given same, therefore constant, therefore lambda is inversely proportional to the 1 upon under root of. Okay. Now, first we take the last illustration. That is short. Due to the reason, first we consider this. Now, what is the de Broglie wavelength associated with an electron accelerated through a potential difference of 100 volt? Here, the potential difference V is given the 100 volt. Right? Now, de Broglie wavelength. Equation of de Broglie wavelength, lambda is equal to H upon P. Just we have this equation in Davison and Germer's experiment. Lambda is equal to H upon under root of 2m EV. And we have also the another form. This equation is 1.227 under root of E. Voltage is given. Voltage is 100 volt. Therefore, de Broglie wavelength is 1.227 upon under root of 100. Square root of 100 is 10. Therefore, 1.227 by 10. That means the 0.1227 nanometer. Right? Thus, we find out the wavelength of the electron accelerated by the potential difference of 100 volt. Okay, this wavelength is in order of wavelength of X-ray. Such wavelength of an electron is in range of wavelength of X-ray. Clear this? So very short numerical. Frequently there is asked in objective type question. Right? For the question of 2 marks in all. So de Broglie wavelength lambda is equal to H upon P is equal to H upon under root of 2m EV. We, by substituting the value of m, mass of an electron, is the charge of an electron, and this value 2. Therefore, we obtain 1.227 upon under root of V. So, voltage is given, accelerated voltage is 100, therefore 1.227 upon 10, therefore 0.1227 nanometer. Clear this? So, these are the illustrations. Okay, now last numerical of illustration 11.6. That is most important and frequently asked for 3 marks. Here what is given? A particle is moving 3 times as fast as an electron. That means the speed of an electron is 3 times more than the speed of a particle is 3 times more than the speed of an electron. The ratio of de Broglie wavelength of particle to that of an electron is also given 1.813 into 10 raised to minus 4. Calculate the mass of the particle and identify that particle. Okay. Now from question what is given? The ratio of the speed V upon V is given to 3. And also the ratio of the de Broglie wavelength lambda upon lambda E, that is the 1.813 into 10 raised to minus 4. From question that is given. Now we have to calculate the mass of this particle. Therefore, we are using the concept of the de Broglie wavelength lambda is equal to m into V. Right? That means first we write out the equation of de Broglie wavelength for particle and also the electron. And from this equation we convert equation of the de Broglie wavelength in terms of the mass. Like to that, for this purpose we assume that suppose mass of a particle is m and mass of an electron is m. Speed of particle is v and speed of an particle of an electron is v. And de Broglie wavelength of particle is lambda and of an electron is lambda. Right? Now, de Broglie wavelength, equation of de Broglie wavelength lambda is equal to h upon p. P is the momentum, therefore h upon mv. Here p is equal to m. Right? Okay. So there is the equation of the de Broglie wavelength. We write this equation for particle and for an electron. For a particle, de Broglie wavelength is lambda is equal to h upon mv. And from this equation, what is the equation of mass? And mass of a particle is m is equal to h upon lambda v. That is the equation 1. For an electron, de Broglie wavelength lambda E is equal to h upon mev. Therefore, mass of an electron me is equal to h upon lambda E into v. Equation number 2. Now we require or we want to calculate the mass of a particle. Therefore, taking the ratio of equation 1 to 2, taking ratio of equation 1 to 2. Therefore, we can write m upon me. M is h upon lambda v into reciprocally multiply lambda e v upon H. H is cancelled. Therefore, lambda EV upon lambda into V. Therefore, mass M is equal to ME into lambda E upon lambda into V upon V. Mass of the electron, we know it, 9.11 into 10 is to minus 31 kg. Now, ratio of wavelength of particle to the wavelength of an electron is given, but here in our equation there is the inverse lambda E upon lambda, therefore its value is in denominator 1 upon 1.813 into 10 is to minus 4 into V upon V. Here the ratio of speed of particle to the speed of an electron is given 3. So here also inverse, therefore 1 by 3. So as we simplify, we can obtain the mass of the particle is 1.675 into 10 is to minus 27 kg. This is the mass of a given particle. Okay, this mass of a particle is approximately equal to the mass of proton. Thus, the particle can be proton. Thus, the particle can be a proton. So, where is the numerical? Now here from the question, the ratio of the speed of particle to the speed of electron is given 3 because the 3 times speed is more, and wavelength of de Broglie wavelength for particle and electron is given 1.813 into 10 is to minus 4. Right? We want to find out the mass of the given particle and also identify this particle. For that purpose, we assume that mass of particle is m, mass of electron is me, speed of particle is v, speed of particle is electron is v. And de Broglie wavelength of particle is lambda, and de Broglie wavelength of an electron is lambda. Now the equation of the de Broglie wavelength lambda is equal to h upon p, therefore h upon m. Now the de Broglie wavelength for a particle lambda is equal to h upon mv, and from this equation, mass m is equal to h upon lambda. Now for an electron, wavelength lambda e is equal to h upon me into v. Therefore, the mass of an electron me is equal to h upon lambda e into v. After obtaining these two equations of mass of particle and mass of an electron, we take the ratio. So our equation becomes m is equal to me into lambda e upon lambda into v upon v. Now we substitute the value. So we obtain the mass of a given particle is 1.675 into 10 is to minus 27 kg. That is close to the mass of a proton. Therefore, the particle can be proton. So here the illustration of this chapter are completed. Very easy illustration, very less number of the equation in this chapter. Now the next is the first numerical of exercise. Now what is the first numerical? Find the maximum frequency and minimum wavelength of X-ray produced by 30 kilowatt electrons. Right? Okay. Now here the voltage is given 30 kilowatt. Therefore, 3 into 10 is to 4 watt. Right? Okay. Now, already in theory of photoelectric effect, we know that HF maximum is equal to E. Right? Now, HF maximum is equal to E. Therefore, F maximum is equal to EV upon H. EV upon H. E is the charge of an electron. 1.6 into 10 is to minus 19. How much voltage is given? 3 into 10 is to 4. and h is the Planck's constant, 6.63 into 10 raised to minus 34. As we calculate, so we obtain the maximum frequency. Therefore, maximum frequency is the maximum frequency of the X-rays is 7.24 into 10 raised to 18 hertz. That is our first one. Now we have to find out the minimum wavelength of X-ray. Now, minimum wavelength of X-ray. So we know the relation C is equal to F lambda. C is equal to F lambda. That means if the F is maximum, so lambda is minimum. So F maximum, lambda minimum. Therefore, lambda minimum is equal to C, velocity of or the speed of light upon F maximum. Speed of light is 3 into 10 raised to 8 meter per second. Upon F maximum, we obtain 7.24 into 10 raised to 80. Thus, we obtain 0.0414 nanometer. That is the wavelength of emitted X-ray at 30 kilovolt. Again, very easy numerical. May be asked in objective type question. So here find the maximum frequency and minimum wavelength of X-rays produced by 30 kilovolt. Here the voltage is given 30 kilovolt. So 30 into 10 is to 3 volt. That means the 3 into 10 is to 4 voltage. Now F maximum, HF is equal to EV. So HF maximum is equal to EV. Therefore F maximum is equal to EV upon H. As we substitute the value, we obtain the maximum frequency of X-ray. F maximum is 7.24 into 10 is to 18 hertz. And minimum wavelength of X-ray, we know that the C is equal to F lambda. That means the frequency and wavelength are inversely proportional to each other. If the frequency is maximum, so wavelength is minimum. Therefore, C is equal to F maximum into lambda minimum. Therefore, lambda minimum is equal to C upon F maximum. Therefore, this value 0.0414 nanometer. Clear this?